Last thing to do in this quick little topic is integrating derivative on function. So at this stage we're not actually going to integrate log functions. X log x minus x, in case you're wondering. And we'll see that later in our, well, I think it's actually more extension 2. Essentially what we're looking at is the reverse of what we did yesterday. So in other words, if we can set the integral up in such a way that we have the derivative on the function, then we know the answer is going to be the natural log of the function, but more importantly, the natural log of the absolute value of the function. So we see something like this. Now we know it's going to end up being a log function. And so the key I'm looking for, certainly when we're looking at polynomial function, is if the degree of the polynomial on the top of the fraction is 1 less than the degree on the bottom of the fraction, we must have a log situation, because when you differentiate the polynomial, the power goes down by 1. So I know that this is going to be a log situation, so I'm looking for derivative on function, and the derivative of course is -3, so I'll set it up so it is -3, balance it out, okay, it's going to be -1/3. So we've got -1/3, the log of the absolute value of 7 minus 3x, plus of course a constant. Integral of dx on 8x plus 5, so same deal. We see it and go, hang on, this has got to be a log situation. So I would like 8 on the top, so I've got 1/8 of what I want. So we get 1/8 of the log of the absolute value of 8x plus 5. Those linear ones are usually easy to pick up because you're basically just talking about a constant on top. Sometimes these escape us, but it's still the same thing if you look at it. Bottom of the fraction, highest power is 6. Top of the fraction, highest power is 5. So degree is 1 less. We've got some sort of log function here. What is the derivative? It's 6x to the power of 5. So let's set it up. That means I've got 1/6 of what I want. So we get 1/6 of the log of x to the power of 6 plus 2. You notice I didn't bother with the absolute value signs there. Why? Well, that's got to be a positive number, because anything to an even power is a positive number. Add to it, it's going to still be positive. So I don't really need the absolute values on that. Well, you still put them there, but it doesn't matter. But that's why I haven't put them on that one. Now this is real interesting. The integral of 1 on 5x. So alright, I would like 5 on the top. So 5 on 5x, I've got 1/5 of that. So the answer is 1/5 the log of the absolute value of 5x. Maybe. But what if I thought about it this way? Because you're allowed to factorise. You can only factorise numbers out of the integral. Like the integral is like a grouping symbol, so you can factorise out. You cannot take the pronumeral out, because that's what you're integrating with respect to. But the constant I certainly can take out. So I have 1/5. Well, integrate 1 on x and I get the log of x. I have a different answer. Or is it? It actually is the same answer. Because on the left hand side, if you were to use your log laws, you could split that log into the log of 5 plus the log of x. Well, the log of 5 is a constant number. So the difference between these two answers is actually what the constant would end up being if you were to work it out. They'd be out by a factor of a 1/5 log 5. This then means it's great fun when you're checking your answers, because the answer that they may provide could well be different to the answer that you have, but that does not necessarily mean that you're wrong. It's also the fun that we have when we're marking your assessments, because we go, oh hang on, they got that answer. Is that actually the same thing as what it should be, and things like that. So it's just one of those interesting things we have to deal with. Integral of 4x plus 1 on 2x plus 1. Okay, that rule I just said about the degree, it's not that situation. Well, that introduces me to another idea. If the degree of the polynomial on the top of the fraction, if it's equal to or greater than, in this case it's equal to, before you integrate, you do a polynomial division. So this one's quite a simple one, and in case you don't think it's that simple, we could go and do our division, and we could rewrite the integral. And then we have the constant 2, which we certainly can integrate. And now the fraction is in that situation where that's going to be a log function. So we have 2x minus half the log of the absolute value of 2x plus 1. Plus, of course, a constant. Let's do a definite one. Okay, 2x on x squared plus 1. Oh, that was a bit nice. The derivative's already on top. So I can go straight to the log of x squared plus 1. Again, you'll notice I haven't worried about the absolute value signs on this one because I know it's going to be positive. Sub in the 2, sub in the 1, use my log laws to bring it together, and we have the log of 5 on 2. Take care when you're doing definite integrals. You cannot integrate across an asymptote. If you think about it as area, well, how on earth can you explain an area where the curve doesn't exist? So that's what I was saying, where you might get questions like this. Differentiate and then hence go and integrate this. Basically, they're just giving you a huge clue about the answer. Although this one's a little bit more involved than a standard one. If I differentiate x cubed log x, then write down the first diff the second, plus write down the second diff the first. Now, that will equal x squared plus 3x squared log x. This one's a little bit more involved because with these differentiate and hence, what you normally say is, well, if I haven't got a clue what the answer is, and I had to guess what the integral is going to be, it's probably going to be some multiple of x cubed log x, because, go back the other way. In this case, it's not quite as clear cut of that because of the x squared that's there as well. So how do I do it? I say, well, I don't know what the integral of x squared log x is, but I tell you what, I do know what the integral of x squared plus 3x squared log x is, because that's what I came from. So the integral of that is x cubed log, now I've put the absolute value in there, plus a constant. I just look at this like an equation. Remember, we have a rule with integrals, you can treat them as separate bits. And so I just move that to the other side. So 3 times the integral of x squared log x will be x cubed log x minus the integral of x squared, and we can integrate x squared, that's not a problem. Add 1 to the power over the power, divide everything by 3, and I've got my answer. Okay, let's add that to our list.